All right, all right, all right. Let's see. Are we live? Hey guys, sorry about that. Of course, when I come on, there's always this software technical issue. So we're on. I believe we're on. Um, Welcome. Good morning, good afternoon, good evening, wherever you might be. My name is Quinn Jacobson, and I do this little Studio Q show when I can. Um, I like to come on, give you guys some technical help if I can in wet plate collodion, um, doing all kinds of stuff other than just the normal routine, as it were. And I like to do these live because it's difficult to communicate when you're doing, delayed. And I'm sure a lot of you guys are going to be watching this after the fact because I'm going to post it up and, blah, 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 all that stuff. But it's nice to have the people that are live here, live. And am I good to go? It looks like I am. Dale's there. Hello, Dale, Peter, Pat. Welcome, guys. It sounds good. I think we have 9 or 10 people in here. So good to go. Can you see my board behind me here? I think I'm on like a 6 or 7 minute delay. God, everybody, yeah. I'm going to try to watch his chat. So when you guys ask me something, questions here, you can let me know. Warning: please check video resolution, which is not optimal. That's okay. We'll go with that. We're fine. So, having said that, let me just close some of these windows down from updating this OBS. I like to go back to this. Can you guys hear me okay as well? I'll try to do a dual screen here. So let's see here. Yeah, okay, good. Pat says, yeah, you can see the board. Everything looks good. Hello, Jean. Long time no here. I did a little thing yesterday where I got on and I rambled for a little minute on a Facebook Live video. I've been so busy with my property that I haven't had a chance to jump on here and do these. And I know I kind of made a commitment that I'd do them every so often. And just, how life goes. Things take priority, and it's good. Awesome. Thanks, guys. I appreciate that, Pat and Tim. Good to see you, Tim. We wanted to talk a little bit, we've had a long break since I've done one of these. And for those of you that have my new book, we're gonna do a little bit out of page 70 to 73. If you don't have my book, don't worry about it. It's fine. Get your favorite beverage. Mine happens to be coffee this morning. Kind of an overcast day here in the Denver metro area. Not very warm today. I've already been out to my forge and I made me a little horseshoe hanger for my gate down on my property and put some chicken in the oven, done all kinds of stuff this morning. It's only 11 minutes after 10. So as the old army saying, we do more before 9 o'clock than most people do all day. Well, if you're a guy like me and you get up at 4:30 in the morning, go to bed real early, it's my most productive time is usually from 5 a.m. to about 2 o'clock in the afternoon, something like that. In the summertime, I go a little bit longer, but wintertime, it slows down to that. So, welcome. Thanks for, yeah, board looks good. Yeah, I agree, Dale. I don't know about the host either. That's good. I don't know where you guys are at. Everybody's in a different spot. Lately, ironically enough, I don't stop answering emails, or texts or messages or all that stuff. So I've been inundated with developer questions and Silverbath questions. And when I say inundated, I bet you there's been a dozen people in the last 2 or 3 weeks that have pinged me about 1 or 2 of those different topics, either one of those topics, Silverbath or developer. Not that uncommon, but I usually see the developer questions come up in the summertime when the heat goes up, humidity rises, whatever, although humidity can be in the winter, and you may be in the southern hemisphere and it may be summertime for you. So I can't really say completely what the issues are. Here's what I think. We're gonna talk about developer or developing positive mostly, but a little bit hit on negatives as well. Developer's an interesting topic because really that's your bread and butter, right? That's how, if your exposure's on, if your chemistry's in good shape, your technique, your developer technique, and how you go about developing the plate is the most important part of the process. And especially if you're making a negative, right? It's one of those things where you're off a little bit and it really shows on the print. So positives, we have a little more latitude. But lately I've been getting a lot of questions about veiling. I'm going to explain what all these are, but veiling, scumming, flat images, lacking contrast, and people start questioning their silver bath at that point. So let's start with what is developer. Let's just talk a minute about what is developer. What is this stuff, and how does it work, and why do we use it? Positives and negatives are pretty much the same on developer. The only difference with negatives is we add more acid or restrainer, and we don't put as much iron or ferrous sulfate in. That's the difference between positive and negative developers. What does developer do? So you have a plate. You've sensitized it in your silver bath for 2, 3, 4, 5 minutes, depending on what you're doing, positive or negative. And you feel like everything's in good shape. You've run a test exposure. You know where your exposure is for whatever type of variant you're working in. And we've talked about in the past, when you pour the collodion on the plate, put it in your silver bath, what happens there? The double replacement, right? We exchange ions and we turn those iodides and bromides into light-sensitive halogens, or silver iodide and silver bromide. That's what's happened on the plate. So when you pull it out, you're now ready to put it in your camera and make your exposure. So if your exposure's on, your chemistry's right, that double replacement or metathesis, whatever you want to call it, all that chemistry is taking place properly. It's occurred in favorable conditions, let's say. You should have a plate mostly covered with silver iodide and some silver bromide on it. So now you expose that plate, you take it in, and you're ready to pour this on it, your developer. And what is your developer? I'll just write it under the positive. Distilled water, right? DH2O or deionized water, iron, acid, and alcohol. Now, I'll talk about this one parenthetically here. But let's give these some different names for just a second. Let's call the DH2O, let's call that the carrier. That's your DH2O. Let's call your iron your reducer. And this will make sense when I explain it. Let's call your acid the restrainer. And I don't really have a name for alcohol other than for flow, for covering the plate properly. We'll talk about that in just a second. So let's talk about the DH2O, the carrier, right? This is the base you're putting everything in to mix it up. What's important about the DH2O? It needs to be ppm 0, or parts per million, parts per billion 0, nothing in it. And it needs to be pH 7, a neutral pH, right? So it doesn't interact, it doesn't have anything in it. That's why you can't just walk up to your tap, unless you're maybe in the mountains or off-grid somewhere and you've got nice clean well water. You can't just walk up to your tap and fill your jug up and pour your developer. I mean, you can, but you're gonna pay for that later, because now you've got organic material that you've used your base or your carrier. You've got organic materials, minerals, deposits, those kinds of things that are going to interact with the halogens on the plate. So DH2O carrier, distilled or deionized water. Iron is your reducer. Let's talk about that just a little bit. And I talk about it on chapter 4 and in chapter 6, both in the book. But iron, or the reducer, what does that iron do? This is the most critical part. And when we talk about iron, we're talking about a 3.8% to 4% for positives, and we're down 3% or maybe less for negatives. What does the iron know? What does it do? Well, when you pour that solution onto your plate, you've exposed it, you've got a latent image on there, You go in the dark room, dark tent, whatever you're working in, you pour the developer on. The minute that hits the plate, that silver iodide and silver bromide is going to recognize that iron as a reducer. And anybody that cooks out there knows what you do when you reduce sugar, onions, whatever in a pan, right? You reduce it. You change its structure. So what happens with the silver iodide and silver bromide when iron comes onto the plate is the iron reacts with those two light-sensitive halogens, and it reduces or begins to reduce that exposed, all silver, but we're looking for the exposed silver. It reduces that silver iodide and silver bromide to the metallic state of silver. That's the end product. That's the reduction. That's what the iron does. So the more iron you have, the quicker and more reactive that's going to be, and that can be with heat and some other things. So we won't get confused here. There's context around this, but so the iron reduces those halogens to the pure metallic state of silver. Now remember, your whole plate is covered in silver, right? So we don't want the whole plate to reduce to silver. We just want where the light, the photons have struck, where you have that latent image, to reduce to pure silver or metallic silver. So what do we put in the developer to prevent the entire plate from just developing? Why doesn't it do that? We have a restrainer or acid. Now, there's two kinds of restrainers that we can use. There's a chemical restrainer and there's an organic restrainer. I prefer the chemical restrainers. Why? What are chemical restrainers? Glacial acetic acid, let's say. Chemical restrainers, and I use a very strong, let me see what, this is 99.7% minimum. This is from the Science Company here in Denver. Glacial acetic acid. Glacial acetic acid freezes at 15 degrees Celsius, 62 degrees Fahrenheit. And they call it glacial acetic acid because when it freezes, very high temperature, right? It freezes and it looks like, it looks like the Arctic, ice in the Arctic. That's why they call it glacial acetic acid. Very high concentration, works very quickly, doesn't take much or doesn't take as much, and it's not messy. Smells bad, corrosive, will burn your skin, blah, blah, blah. What's an organic restrainer? An organic restrainer would be something like white sugar, molasses, honey, beer, a heavy beer. And how they work differently. The organic restrainer takes space up and it prevents this reduction. The iron, it blocks it. It's like crowding and it's like a physical reaction. The chemical restrainer works on that principle. It works chemically. It changes the structures chemically. So it's more abrupt. Like I said, it doesn't take as much, etc. I do have recipes for sugar. Sugar is sticky and messy, and it works well if you can't get glacial acetic acid. But you can go all the way down to like household vinegar and use that as your base. So let's talk about how that breaks down too. Household vinegar as a restrainer, I'll just say household vinegar. The white stuff you have in your cupboard is about 5%. Pickling vinegar is about 10%. And then we get acetic acid is about 30%, maybe a little more. And then glacial acetic acid is, we're up there in the 90+%. Just depends on what variety you get. So I use the strongest restrainer for reasons I'm going to explain here. What does the restrainer do? Again, it holds back that iron. It blocks or chemically reacts with the iron. So you have time to develop your latent image out, reduce the silver where the light struck the silver, or the iodides, the halogens, reduce that down to pure silver and leave the rest alone. So when you come out of the dark room or dark tent and you look at your plate and it's covered with this layer that you can take a cotton ball and drag over, that's all unexposed silver that you've reduced. That means your temperature's too high, your exposure's off, you went too long with your development, you don't have enough restrainer in your developer, all those kinds of things. What happens if you have that same flat veiled image? That's why they call it veiling. That same flat veiled image, and you put a cotton ball on it and you run it across and it doesn't wipe off. That is a problem with your silver bath. That's an acid problem. That's a pH problem. That's a light leak. That's something else going wrong there. So we've got the carrier of water. We've got the iron as the reducer, taking that down to the state of metallic silver. It's showing your image. And we got the acid or the restrainer holding everything back so you can get to that state. Now you're to that state. So people ask me often, and there's a lot of science here and a lot of variables. So I don't want to. I'm painting with a very broad brush when I give you these explanations. If your silver bath's in good shape, if your developer's in good shape, if your temperature's right, if your exposure's right, if all your conditions are right environmentally, you have a proper exposure. With the variables we talk about in my book, I can't speak for anyone else's stuff, but I can speak for the content of my recipes. If everything's right, you're going to go in a 20 degrees Celsius environment, a 68 degree Fahrenheit, between 20 and 22 degrees, 68 to 73 or 74 degrees Fahrenheit. You're going to go in, pour that developer on, and once that developer breaks that meniscus and hits that iron, hits those halogens and starts the reaction, you're going to see highlights appear in 3-4 seconds, something like that. Your brightest area, the most exposed area, is going to appear in about that time. 7, 8, 9 seconds, you're going to see the midtones start to form. You're going to see the mid-ranges start to form on your plate. And then right all the way to the end, you're going to start seeing shadows form around 12, 13 seconds. Once you see a shadow on the shadow side of an image, you have, say you do a portrait, this is the bright, this is the shadow. Once you start to see some detail here, an outline of a shirt against the skin or something, once you see those shadows start to form, you start pouring water or putting water on that. What happens there, you have to break that meniscus, and that iron doesn't wash off immediately. So you have another 5 or 8 seconds. So while you only go to 15 seconds to pull your image in fully, that's again, if everything's right, you're going to really develop the plate for 20 or 23, 24, 25 seconds total, because you're pouring water on. It's still greasy. That's still developing. Anytime there's still that greasy look to the plate, you still have some development going on there. So why is this 15 seconds? Well, again, everything being equal and proper, and content, concentration, environmental variables, all that being equal, that's what these concentrations and these temperatures and these conditions with the proper exposure show to produce the best image. What do I mean by the best image? I mean an image with a lot of tonal range. Here's what gets me, and I don't want to be critical. I hate speaking in the pejorative. It's just the fact of the matter. Most images that I see posted online, or have in the past anyway, I haven't looked a lot lately, but are overexposed. Positives. I'm talking about positives. Most of the images are overexposed. And what happens when you overexpose a positive? What happens is you start losing those mid-ranges, which makes an ambrotype or a tintype, a ferrotype, whatever positive you're making, or acrylotype, a lumotype, whatever you're doing. What makes those positive images so beautiful is what you lose when you overexpose. And let's talk about what a positive really is. A positive is a very thin or underexposed negative. There are no positives in wet collodion. We underexpose, we put it against something black, we use reflected light, and we show the image. So to get the maximum quality from these images, all conditions, all variables being correct here, exposure, you need spot on. You need that exposure, just not too much, not too little. If anything, you want to err on too little, because once you cross that line and you overexpose a positive, you start losing that tonal range. You're basically reducing silver in those mid ranges and putting a lot of silver in there where it should be, glass or black metal or whatever you're doing, right? So I see most of the time I see people overexposing positives, not giving it that wonderful tone range that these things can produce. And I think when you talk about a well exposed ambrotype, especially my personal preference on black glass, you're talking about one of the most beautiful images that this process can produce, in my opinion. A properly exposed black glass image, the tonal range, the depth, just everything about it. But if you overexpose just a little bit, I often do this in workshops. We'll set a scene up, we'll photograph it, we'll get the exposure on, and then we'll expose it a second over or 2 seconds over. And you compare those two plates next to one another. When they're separated, the overexposed, oh my God, that looks great. The overexposed plate looks just fine to the layperson's eye, or even if you don't have a comparison next to it. Once you put a plate next to a properly exposed ambrotype and a slightly overexposed ambrotype, you'll see exactly what I'm talking about here. It's amazing what a little bit of overexposure will do. Let me just check here. So we've reduced that silver, those iodides, those halogens to the metallic state of silver. We've here we go, Pat. What does over-underexposure look like? That's yeah. What does over-underexposure look like? Well, let's go to, if you have my book, let's go to page 102. Over, where am I? Over, and these are reproduced not so well. There's over and under, and here's a proper. Let's start with the proper exposure. I don't know if you'll be able to see the detail. Proper exposure, and then over and under, right? So what happens when you overexpose is you lose all the tonal range. You pack it with silver. When you underexpose, you don't give it enough, and you end up with clear glass or black metal or whatever you're doing. So that fine balance there, that's what you want to strike. That's what you want to hit. That's why, honestly, I see so few properly exposed positives. Most are overexposed. And then what people, and that's fine. If you want to do that, that's fine. Here's the advantage of slightly overexposing your positive. Let's talk about some constructive criticism and actually positive things about making positives. How about that? Positive things about making positives. You slightly overexpose an ambrotype on glass. This doesn't work with anything else, on clear glass. What you'll have is you'll have an image that you can now take. It'll look decent, like I said, as long as you don't compare it with the properly exposed same scene. You'll have a decent positive glass ambrotype, clear glass ambrotype, CGA, and now you can take that and put it in a larger, or put it on a piece of modern developing out paper, like modern Kodak develop out or Ilford develop out paper, the chemical paper, right, the silver gelatin paper, and they make wonderful prints. They make wonderful prints. Not dense enough. You haven't gone all the way to make a negative. We'll talk about that in just a minute. You haven't gone far enough to make a negative, but you've gone enough. You put enough silver on there to make a nice contrasty silver gelatin print. Never an overexposed positive just turn into redeveloping. Yeah, that's a good point, Dale. There's another thing you can do, and that's what I was going to talk to you a little bit about. So you have a scene. You've overexposed the plate, and you're on clear glass, right? This is only for clear glass. You've overexposed the plate by a second, 2 seconds, something like that. Once you get up past, and again, painting with a very broad brush here, general statements. Once you get past to a certain point of overexposure, you're going to begin to lose density. That's what happens with this process. So if you're just a second or 2 seconds over on your positive, and it's very bright when you put it against a piece of something black and you reflect the light back to you, and there's a lot of silver on there jumping out at you, what you can go ahead and do is you can go ahead and redevelop that with iodine, pyro, and try to produce a negative out of it. So here's the dilemma with wet plate collodion. It's very finicky. The ambrotypes require a very thin or underexposed negative, and when I say negative, I mean wet collodion negative, not your film negative. And a negative requires a fair amount of density, which means it's going to go past a film, kind of plastic film negative, but not so bulletproof that it's, you know, that it won't print. So there's a fine line there, because what you're doing with the wet collodion negatives is you're contact printing them on a salt, albumin, collodion chloride, something like that, you know. So there's this, you have to pick or choose. But when you have a slightly overexposed ambrotype, and that's what I recommend, you read chapter 12 in my book, or chapter 11 in my book, and chapter 12 is printing. In my book, I recommend that what Archer says is for a negative, he goes 1.5 to 2 times an exposure for a positive. So let's do the math on that. Let's say your, let me erase some of this stuff. Let's say I'm terrible at public math, so I'm going to do something easy. Let's say your exposure for a proper positive is 5 seconds, and it looks really good. You could go for a negative, you could start at 7 seconds, and you could go all the way up to 10 seconds. I find that I'm usually somewhere in between here. Usually. And again, very broad brush that I'm painting with. So this would be my negative, and this would be my positive. So that kind of shows you the difference in exposure, and that's everything being equal. Now, I haven't talked about the negative developer much yet, and that's really important, because when we take that overexposed ambrotype into the darkroom, and we're going to develop it, not redevelop it. This isn't an afterthought. This is pre-planned, right? I made 52 negatives I have on the racks over here from my ghost dance work that I just finished this year. Chapter 13, I think I have 22 images in there of ghost dance. I have 52 images of ghost dance, all 6x6 wet collodion negatives. So every plate, I didn't make one positive. Every plate I went in with the intention of making a negative. So I start out with a very different exposure. Sometimes I did run a positive just to see what the exposure was, and I'd check the plate. Sometimes, I guess I have a few tintypes over there that are test shots in the field checking what the exposure was. But this is the recipe I use to find out if this is a good positive. This is somewhere between here and here is a good negative. It just depends on how much I want to redevelop, or if I want to redevelop at all. And I usually do, or I have in the past. So let's talk about the negative. That's a good segue to the negative developer. I talked just a little bit about the difference in what we're talking about here. It still has the DH2O, check. It still has the iron, but what did I talk about the iron difference? If you go to, I'll give you the page number here. It's chapter 11 here, pigment prints. If you go and look at let's just talk about the recipe here. There's chapter 12. Making negatives. Just do a little intro here. Let's talk about the negative developer. Where's my marker here? So in my positive recipes, I use between 3.8 and 4% iron, or 38 grams to 40 grams per liter. We jump down here to negative. Look at what happens. 20 grams, or I like to go percentages, 2% iron in negatives. And we'll talk about why. Acid, let's jump and say on my positives, I'll have to turn back and see. I think I'm at a 5% or 6% on my positive. Let's see, chapter 6. I have to actually look sometimes myself. Chapter 6, the positive process. Sorry. Chapter 5, making chemistry. Just so I'm not I misspoke yesterday. For developer, for positives, I use, it's been that long since I made a batch of positive. I use, God, if I can get to the page. They're in order. So I use 4%. Okay. So I use 4% acid up here. And look what I use down here. 8%. And that's a starting point. So I double the acid. I drop the iron in half. I've halved these now. I use 50% in negatives for developer. And now, and we haven't talked about alcohol. We will in just a second. These are the critical ones here. So now I want to talk about, why do I use 40 grams a liter here, 20 grams a liter there, 80 mils a liter here, and 40 mils a liter there, positives and negatives? For two reasons. The first reason is that you, on a negative, you want to bring everything you possibly can. The tonal range on a good negative is unmatched. Like I said just a minute ago, a good positive visually is stunning. But once you do the same, apples to apples on a same scene on a negative that's properly done and a print, you will see a tonal range you've never seen before in your life. It's the only thing that can match. It's the only thing that can produce a tonal range like that is the wet collodion negative, properly done. And wet collodion negatives aren't bright ambrotypes printed on silver gelatin paper. They're just not. I'm going to watch the chat, so I'm trying to watch that in case somebody wants to jump in. So positive and negative developer are different in concentrations of the reducer and the restrainer for the two reasons. One, you want to get in and out on a positive. It's a very thin negative. You don't want to overdevelop it and bring so much of that image up that you're going to you're going to destroy your midtones. Well, not destroy them. They're going to be super bright, and you're not printing it. So you're using reflected light, not transmitted light like a print, right? We use transmitted light for negatives and reflected light for positives. Keep that in mind. It's very important. If it doesn't make sense to you now, it will in the future if you keep working in this. And secondly, you wouldn't have the time. You would not have the time at doubling. You saw what I did there on my exposure. I went from a 5-second positive to an 8 to 10-second negative. There's no way with that type of exposure that you could run that strong a solution or that strong a developer on there. You just, no way. You'd veil the whole thing. You develop all that unexposed silver. Once those shadow areas are plugged on a negative, if you redevelop or if you go to print, if you redevelop, you're just going to build those. You're just going to plug the entire image up. So it needs to be a clean image with proper concentration, proper environmental variables, and proper exposure, and the intended outcome, either a positive or a negative. Does that make sense? I hope it does. That's kind of my spiel on positive, negative developer and how it works and why we choose to use those things differently. Let's talk about alcohol. What is alcohol? I just wrote up there a minute ago. I said flow. So if you have a brand new silver bath you've never used, and you just made your first liter of silver or half liter, whatever you're using, and you made your first developer, well, guess what? You can ignore the alcohol. You don't have to put the alcohol in there. The alcohol, let's talk about the function. What I mean by flow or viscosity, viscosity, flow, I guess, however you want to say it. What happens when you pour developer on there, there's going to be resistance on the plate, especially if it's a worn silver bath. My silver baths, I hit them hard. I use them for years. Even with maintenance and everything, I hit them. I just really work them out. And once those solvents from the collodion, you're putting a half damp plate in there, 10, 20 times a day. Once those solvents get in the bath and those iodides and those byproducts from the double replacement, all that combined, all those contaminants, when you pour that developer on that plate, you're going to have resistance. And you want that developer to flow over your plate without starting and stopping. If you start and stop on your developer, you get a hole that doesn't cover. Those are islands or sweeps. Alcohol will prevent that from happening. You don't have to use it on a fresh batch. You can leave alcohol completely out. And once you start seeing those sweeps happen, you're going to have to add a little alcohol to your developer. It's just the nature of the beast. What is the downside of the alcohol? Well, if you look at it and you think about the chemistry, ethanol, 95% ethanol and 5% water. What you're doing is you're reducing the effectiveness of the developer by just a little bit. So if you're a negative maker and you start out and you have a clean bath, never been used before, and you have a developer that you don't have alcohol in it, you might see punchier negatives. You might see punchier even positives, right? And my head's been in negatives for so long now. I have to switch gears a little bit, but you might see a little bit improvement without using the negative or the alcohol. And I've seen it in negatives. When I make a fresh silver bath, which is very, very rare because, like I said, I just run them to death. I can leave the alcohol out, and man, those both positives and especially negatives are really, really punchy. And it takes a very discerning eye to tell the difference. But I make all my developer with alcohol. The worst thing that people can have happen by not using enough alcohol, you'll get those sweeps and islands, and people, you do a portrait and you don't have enough alcohol, or your bath's worn hard and you did put alcohol in your developer, and you'll get a big hole in somebody's head or islands on the side, and big sweeps where it starts and stops. A lot of times problems even going into the silver bath. You'll get bubbles, you'll get streaks, you'll get dipping hold the dipper, the bottom of the dipper, if you have it holes in it or marks, you get all kinds of stuff going on. So those are kind of some of the problems that you'll face if you don't add a little bit of alcohol in your worn silver bath. Again, if you're just starting out, don't put alcohol in your developer, and your silver bath will take care of it until you start seeing those sweeps and islands. That's probably the first two things you'll see. Any questions on developer? I'm going to move on to silver bath here for a minute. Anything there? I'm going to keep my eye on this so we can see it. So let's talk about silver bath. Silver bath, our favorite topic, right? What is a silver bath? Let me erase this here. Developer and how it works. Awesome. I'll put Agno 3 up at the top. Ag, nitrogen, silver, nitrate, bath. It's easier than writing it all out. Agno 3 bath. What about copper? Saltpeter. What about copper? Okay, we're not going to leave developer quite yet. Let's talk about that. Saltpeter, potassium nitrate, right? So what does saltpeter do? Here's the thing. Dale's asking, I guess he's asking, he says saltpeter. What happens when you add saltpeter, potassium nitrate, to your developer? That's actually a little bit of a restrainer. And what you're going to do is you're going to shine up the reduced silver on your plate. So if you talk about a less punchy image, like if you leave alcohol out of your developer, but you put potassium nitrate in it, the potassium nitrate or saltpeter is going to do far more restraining and reduction than the alcohol or the problems with the alcohol that you might see. So no problem doing that. You'll read, 4-6 grams, 4 to 6% in a liter of developer. Very common. Images tend to be silvery to me. They tend to bring out, they don't leave that color, especially that nice warm color that I like in a positive anyway. And they tend to be a little more silvery, kind of like adding too much nitric acid to your silver bath will increase the contrast, slow the bath down, and make images more silver or cool looking, kind of like a silver gelatin print versus this kind of warm tone that we have in Collodion. What about copper? Yeah, Jean. You know, yes, you can use copper. It's not. I think that's a little bit hype, a little bit of hype. It's not as effective as a reducer as iron. Period. That's just that. Those are the facts. Iron is a better reducer than copper for silver halogens. Um, if you know, I think sometimes wet plate's gotten so commercial now. I think sometimes people just look for an avenue, different types of collodions and, you know, different developers and, most people don't even understand how the process works. So you're not going to see a whole lot of difference in a in those variables and using those different products. You're just not going to see. If you look at all the primary literature, most of the primary literature, and I have it, most of it right over here on my bookshelf, you're going to see the dominant recipes are iron, acid, and fixing with cyanide. Those are developer and fix. Those are the things, and maintenance to your silver bath. You're just not going to see. I will say this about, okay, if you want to challenge me on Collodion, I don't care what these. I asked somebody the other day on the forum board or on one of my face bag pages. They said something about an old dead woman or old dead bride. Old dead bride. I said, what is old dead bride? And I said, that's your quick clear recipe modified. And I looked at it. The recipe I found, they had 0.2 of a gram more of cadmium bromide. And he talked about it was faster, ISO, things like that. And and then he said they put the recipe I saw didn't have the Ki or potassium iodide in it. But if you did put potassium iodide in it, I could see where you're not going to have that those iodides oxidize as quickly. But here's what I will say about collodion, or different recipes for collodion. The two different recipes that I have are Quick Clear or Quinn's collodion, or some people. It's a Waldeck modification. It's not mine. Well, I guess it's mine because I modified it, but it's Quick Clear, meaning that I use NH4I as the iodide that oxidizes and turns red quicker, and we can talk about that if it's interesting to you, and Ki, or potassium iodide. That is not soluble in solvents. So you have this fallout. Yes, you still have iodides in the solution, but it's not going to oxidize as quickly, hence not turn red as fast, hence keep you at ISO 2 longer. So you do have a longer shelf life, 1 or 2 ISO ASA speed difference in Ki versus NH4I, but what you get with the speed and the shelf life, sometimes you'll lack the tonal range. But if you overexpose everything anyway, it's not going to really matter. So my Quick Clear, what you can use right away. I can mix it up here, especially if I oxidize my NH4I. I can mix up a batch, pour a plate, go over and make an image right now. Shelf life on it, if I store it in a dark, cool place, I can use it for months and still have a good color and very usable. I like an orange. If you look in the book, my biggest claim to fame here, right? One of my little illustrations, my graphics. If you look on page, I'll show it to you, but I just have to find it here. Sorry. If you look on page, I don't know what page it's on. No, that's light. Would be in Collodion. I just want to show you this little illustration. This is my kind of claim to fame here. My favorite color is right in here, these two colors right here. And I match up with the silver bath there, and you can read about that. We'll talk a little bit about how that works. But that's basically your main component in making an image is Quick Clear. Could a Quick Clear, hey Gianni, could a Quick Clear also using potassium? Sure, yeah. In fact, that's what I said. I don't remember the gentleman's name the other day on Facebook or whatever. That's what he said. The old dead woman or old dead bride was. It was that recipe with potassium iodide. I guess what you could try, you're kind of defeating the purpose, because the Ki or the potassium iodide is not soluble in those solvents, ether and alcohol. So what you're doing is you're trying to, over time, you have a year shelf life on that, or 8, 9, 10 months anyway, but it's going to take you a little longer to use. You can use it right away, even if it's cloudy, but you're not going to have that tonal range, especially making positives or even negatives. You're not going to have that tonal range you're going to get with a quick breakdown, a quick clear, meaning the iodides break down quicker. You get that nice orange color. Colors are really important. I've never understood why these people put collodion in these amber bottles. You got to see what color your collodion is to know where you're at, right? You've got to see the breakdown of those iodides. So yeah, you can put, let's put it this way, you can put anything in anything you want and make anything on anything. What your results, that'll be a different question. Your quality, shelf life, workflow, what they call injuring other components in the process could be relative, especially when it comes to silver bath. I'll talk about that right now. But yeah, you can do anything. I mean, it's all out there. There's so many crazy recipes. There's hundreds and hundreds and hundreds of recipes for this stuff. And you can do whatever you want. Try it. If you got the money and the time, mix that stuff up. Throw frog's piss in there and see what happens. Who knows? You can try anything. Anything else on developer before we move on? Get me a little coffee going. Gianni, yes, you can. I just answered that. Also using, yep. And I think that's called Old Dead Bride. If my sources were correct, I don't even know who names this stuff. Kind of like cannabis in Colorado. They've got all these crazy different green crack and your mother's room and, strawberry killer and whatever, people just make up names for these cannabis cultivars. It's kind of crazy. And I guess now they do it with recipes. Size of the silver molecules, they're tiny. What do you mean size of the? Yeah, well, they change, right? They change with temperature and concentration. Yeah, they get bigger and smaller depending on what your environment and your chemistry. I like grenadine marsh. That's good, Marcus. I like that. Yeah. So yes, you can do anything you want with any chemical. It's all the old one I mix together. Yeah. Oh, yeah. I do the same, right? I don't have that often, but that's a great question. We're not even talking about clothing, but you guys can steer this conversation wherever you'd like. Let's say I have. Oh, you want to see some old red collodion? Oops, sorry. Let's pull this. Oh, if I have any. Yeah, I do. So there's some in the original 1 liter bottle, and there's the drain bottle from it. That's pretty red. So why do I keep this around? I keep this around, like Marcus just said. I keep it around just for the simple fact that sometimes if I do a KI batch, I can chuck a little bit of that in there, and it'll ripen up. It'll speed up the oxidation of the iodides, and then sometimes if I have 2 batches, half one the other, mix them together, no problem. It's all mixed together. And Gianni says, what I am saying is that even using potassium iodide, the collodion don't need to ripen. No. You don't need to you don't need to ripen it. The quality of your image, here's the thing, guys. You can do anything you want, and you can get an image. What I talk about is what quality of image is that? What are you comparing it to, right? So we're not excluding things like that. We're saying what's the quality of the image that you're getting with these variants or these different compounds that you're using. So you can put potassium iodide in quick clear and use it. Sure, absolutely. And not ripen it, not do anything. I go by the color of the collodion. It tells you what your iodides are oxidized and what kind of tonal range you'll get from that. That's what I go off of. So, Jean, brighter plate equal large silver molecule. Yes, you are correct. And more, not only larger, but brighter, more reflectivity. Yes. What's the better to influence that? With developer, less acid. Yes. Overexposure, longer development, and less acid. Yep. You can, I don't know. That's what I see most of the time are overexposed positives with a lot of silver on them. A lot of reduced silver. So, let's talk about, can we talk about silver bath? Because I only have a few more minutes left and I got some obligations, but we will be back. I promise you we'll be back to do another one of these shows soon. Absolutely. So, let's talk about the Agno 3 or the silver nitrate bath. Real quickly. What is the purpose of the silver nitrate bath? The purpose of the silver nitrate bath is to perform the double replacement or metathesis on the plate. Okay, so hold on. Pat's got a question here. Mr. Doyle, he says, in your book, you point out the need to keep KCN and acids away from each other. Absolutely. Great advice, obviously. You say not to store them near each other. How close is too close? How do you store them? Very good question. Thanks for, and you guys jump in. I'll keep my eye on this chat board. You guys interrupt me. I'll go back to my train of thought on this. No problem. Pat, what I talk about there is a clean, clear separation of any acid and nitric, glacial, any acid, and a mixed solution of potassium cyanide. So, for instance, if I'm in my dark room, my 2-liter potassium cyanide is at the end of the tray over here, and my developing takes place in another tray far away from that. And then also the rinsing and the cleaning of the plate is really important. If you ever see that blue haze, that Prussian blue, you've left developer or iron on that plate, on your developer, and you pour the cyanide on. Cyanide and iron mix forms Prussian blue. It tells you didn't get all your developer off, meaning that you have acid in there that's, I don't know what the formulation is, how much it takes to create hydrogen cyanide gas. We're not going to find out, but a clean, clear separation. When traveling, you want to take your acids away from your developer or your fix if you're using cyanide, if that makes sense. Store them in different places and sealed. I use seals. I seal like that, sealed up. Mr. Brown, Tim Brown, a properly developed tin type when viewing under indirect light or dim light might look underexposed. Is that just due to lack black background of the tin? Absolutely, Pat, you're very welcome. Tim, let's see. A properly developed tin type when viewing. Yeah, see, that's a very good point, Tim. What happens, people are used to seeing silver gelatin prints, or let's update it a little bit. People are used to seeing pigment prints or inkjet prints, and they don't require reflectivity of the silver, right? So you can see the image. That's why, in the first gallery show I ever did many years ago with all positives, I had to have the gallery reconstruct their lighting system because I needed direct light and preferably 5600 sunlight value, Kelvin temperature, on the plate to reflect the and properly see the tonal range in that image. Basically, here's the thing. A properly exposed positive, ambrotype, tintype, ferrotype, should look great in the very light it was created in. So if you create it in sunlight, if you create it in studio light, put it in that light. And you're right if it looks good in that light, right? So, and some say theoretically every positive should be viewed in 5600 Kelvin sunlight light to look proper. So if you put it under a 3300 Kelvin degree tungsten light, or you have these weak, 100-watt lights in a typical gallery, or you're just not going to get that reflectivity. And especially if it's a properly exposed positive. If it's overexposed, and that's why people overexpose positives, because they show better. They look. You don't require that light. That's kind of a thing. It's easy to understand. I mean, I know why people do it, or They don't even consciously say, I'm overexposing this by 2 seconds. What they're saying is, man, that looks good in sunlight over here, but not in this kind of incandescent light. So I'm going to jack the exposure up a little bit. So now they got a bright tintype or ambrotype, and it looks good in very low light. Or again, it looks good until you compare it to something that's properly exposed in the proper light. This is all about context, guys. Both chemistry, exposure, the visuals, all that needs to be in context to really get what I'm saying. And I'm painting with a very broad brush there. Does that make sense? I hope it does. And we will go ahead and move on to silver bath now. What did I just do? Nothing. I just expanded my window here. Full screen. Uh-oh. Let me go. Let me do this. I got to watch the... Marcus, perfectly explained. I just had to explain that too. Excellent. Yes. And that's what you should do. That's a great point, Marcus. You should try to help once you understand the process. Not only should you evangelize that to your fellow wet plate people, and if you teach it or you're doing demonstrations or you have customers and they're interested, explain it properly. There's, in business and education, teaching this like I've done for many, many years, or demoing it, all the universities and colleges that I go to and everywhere I've been. What I try to do is I try to go in with the confidence, understanding the process. So people are amazed by it. We all know that. And they want to know how it works. And you need to understand how it works. Number one, you need to understand how it works so you can troubleshoot and fix the problems, improve your image quality, blah, 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 whatever, save your money, whatever. But even in business, if you're doing it commercially, let's say, and a lot of folks are doing that now, explaining it to a customer it's really, I think I try to stress the point, and you've heard me say this a million times, it's really important for people to understand how the process works if they're working in it. And if they're teaching it, please understand the process, because now you're in safety and all kinds of other things. So try to learn the process. And that's why I want to do these little shows to try to help people understand it a little bit better, and not just, I did a workshop and really what it was is a demonstration. They poured a couple of 4x5 plates and they're off and going. And that's fine. But I always say first things first in that order. You should really learn how the process works, and especially the safety and the storage of chemistry. Even if you buy chemical kits, I mean, that stuff, it's still dangerous. Even if you don't use ether, there's ether in the collodion. Even if you don't use KCN, there's a lot of flammable stuff, a lot of dangerous stuff in the process that can go awry. And, I've had conversations I've got an accountant and attorney and publishing books and teaching workshops and going to university and things like that. And I've had conversations about what is my exposure on liability for when people buy my books and do this. So I'm a real stickler about, understanding how the process works. One of the things I just saw on the board the other day, somebody said, I can't get my silver. Is this the point where I boil it? And man, you guys know how I feel about boiling silver, AgCNO3, it's bad news. And if you don't know about it, go research it. Silver fulminate. I just don't mess with that stuff. It's just not worth it. I love photography. I love these processes, but there are some lines I will not cross. Ether, KCN, no problem. 20 years doing it, I'll handle them, no problem. Boiling or heating silver baths up, no. They did it in the 19th century, of course. Read Bill Jay's Dangers in the Darkroom. You'll read all about explosions. Number one killer in the 19th century. Number two, poison. So let's move on to the silver bath. You're welcome, Tim. Absolutely, you're welcome. Thank you for the questions. I like the questions. Good questions. Like to have the Q&A going on here. Agno 3 bath. What does the Agno 3 bath do again? Just real quick. The AgNO3, or the silver bath, silver nitrate bath, what it does is it performs or allows this double replacement process to happen. What is the double replacement process? Well, you have or at least two salts in the collodion, right? Or one salt, whatever you're doing. Let's just say 2 salts in the collodion, an iodide and a bromide. You mix it in the collodion, you pour it on the plate, you drain it off, you put it in your silver bath after it's skinned over, right? So what happens there? The silver nitrate and the iodides and bromides start talking to one another. So the AgNO3 says, hey, here's the AgNO3. talks to the N. I'm going to use my recipe, NH4I or the Ki, whichever one you want. AgNO3 says, hey, Mr. Iodide, how about we exchange an ion? The iodide said, yeah, let's do that. So what happens is you have an exchange of ions, and you form AgI. What is AgI? That is silver iodide. The AgNO3 talks to the CdBr, or whatever you want to use, right? If you don't like cadmium, that's fine. Whatever you want to use. And we exchange ions. And what do we form? AgBr, which is silver bromide. So those are your two light-sensitive halogens. That's the main function of a silver nitrate bath. In order to do that and do it properly, there has to be all these things in play, all these things around it to take place, for it to take place properly. We talked about temperature. We talked about the amount of compounds you have in your collodion, the type of alcohol you're using, how well your bath is maintained or not, your silver bath. So it goes on both sides. So if everything's just right, you form these two light-sensitive halogens, and you're able to now go to your developer, like we just talked about, and bring that latent image out after you exposed it without veiling, proper density, proper tonal range, all those things. The silver bath, I hope that makes sense to you guys. The silver bath, that's called double replacement or metathesis. The silver bath requires maintenance. Why do you require maintenance? Well, think about it. You have a plate that's pretty wet with collodion, right? We let it skin over, so we're not pouring a plate on there and dropping it in right away. We let it skin over so it has that kind of pudding skin on it, as we say. Let me get a drink of coffee. So it's skinned over, goes into the silver bath tank, but it's off-gassing. It's bleeding off solvents, alcohol and ether. And this double replacement process produces, and if you have my book, let me just take you to the page. I think it's chapter 10. I'll find it here. Chapter 10, Silver Bath and Darkroom Notes. Here's another little, here's my new illustration. I hope you saw my collodion one with the different colors and the percentage of baths and how you maintain, how you deal with those for image quality. Here's my double replacement. That's on page 116. So let's talk about that. So we have these wonderful silver halogens, silver iodide and silver bromide. But guess what else happens? We have solvents in the baths, right? In the silver bath, the byproduct of putting a semi-wet damp plate off gassing those solvents. And now we have leftovers from double replacement. Let's talk about what those are. We have here NH4NO3, and here we have cadmium NO3. So we have cadmium nitrate and ammonium nitrate. Those are the two waste products that produce in the double replacement, the double replacement process, producing these two. These are the byproducts, plus we have solvents. So you're filling your bath up fairly quickly with these contaminants. That's what they are, really, right? They're contaminants. So if you have your silver bath, let me find one of my silver baths here. Oh, I can't reach it. Maybe I can. This is a half a liter. So if you open your silver bath up here, this is my number, what is that? My number 1. And smell your silver bath. And if you have a strong alcohol or ether smell in there, it's time to at a minimum, let it breathe. I started writing now in this new publication, this new book of mine. I'm putting more emphasis on aeration or as much emphasis on aeration as sunning or bringing your bath, letting all the organic material kind of print out and fall down. This stuff is almost impossible to get rid of. That's why people boil their silver bath. And in the heavy maintenance, as you neutralize it, bring everything down, you use baking soda or ammonia, something like that, you're going to pull a lot of these byproducts out, and you'll basically have a new silver bath. But that's the byproducts from the double replacement, and you've got solvents. You can resolve this by letting your bath breathe, and you can resolve these with heavy maintenance. Now, these aren't going to build. This isn't something you have to concern yourself with day to day, or even month to month, or possibly even year to year. This is something in high volume. Negatives are going to be more affected by this stuff than positives. One of the common things on a silver bath that you get when you need to do maintenance on it, or heavy maintenance, is you get pinholes. That's iodides literally falling out of solution, precipitating out and landing on the emulsion. You'll get little tiny pinholes. They'll be all over. And boy, prints look terrible. Sometimes you can get away with positives with it, but they're terrible. So there's without doing maintenance, ammonium nitrate, cadmium nitrate byproducts, solvents from putting plates in to get your two light sensitive halogens to make your image. I hope that makes sense. You guys can let me know. Anything else? I'm going to just erase this stuff. Anything else you guys want to talk about? I have another 15 minutes or so. What do I have a red dot on that? Oh, just because it's running. Okay. Does that make sense for you guys? Let me know. Give me a good word here. Let me know that we're still all on board. I haven't been talking to myself, have I? Does that make sense? Give me a shout out, somebody. Are you still there? Yeah, you're there. So, I hope that explains developer, how development works, and I hope it explains a little bit about silver bath. We didn't deep dive on silver bath, but we can definitely do that. Nope. Yes. Oh, good. Thanks, guys. Yeah. Don't be afraid to chime in here, because I'm running. All I see is a computer screen, and I want to know that you guys are still out there. Oh, good. Okay. Thank you. Don't be afraid. If you have any questions, shoot them out right now. And I think I have a 6 or 8 second delay here for some reason. I'm not really sure why. So if I act a little weird, don't worry about it. So shoot out any questions. And if I don't get any questions in the next 30 seconds or so, we'll wrap this baby up. So we've been 1 hour and 8 minutes. That's pretty good. It did say I'm running kind of a high resolution, so if I choke and puke, I'll adjust that next time. From earlier, Peter. Excellent. From earlier. Just got my first pets full. Amazed at how much less light I need in the studio. Yeah. If you have any time to spare, could you give us some pointers on shooting with Petzval lenses? Yes, I can, Peter. Petzval lenses, obviously, I hope it's obvious, are my favorite flavor of lens. Not just for the speed, but that's a very good point you make. You know the story of Josef Petzval, the Hungarian mathematician that designed these optics, the front group air gap, the rear group glued, convex concave. And we went from 20-minute exposures to 20-second exposures. One thing I will, and it's a great question, Peter, one thing I will mention is that when you're using Petzval lenses, make sure you have a large flange because Petzval lenses will tend to take light in, scatter it around, and give you flares. And I've had that happen many times. Petzval lenses, especially wide open outside, can be problematic. So you want to shade them, an umbrella. You want to have a large flange over the lens, something like that. Other than that, just enjoy them. I'm a frustrated painter, so you can imagine I love the look of the Petzval. And boy, it does help with time. One of the things that people tell me is, "Oh, I like your collodion, your recipe for collodion, but it ripens so fast. I lose speed, and I want the speed." So one of the things that Petzval lenses do for me is I don't have that problem. I can shoot with 300 watts over here. Use my actually have a 2.8 Darlot or Derogi, sorry, Petzval lens, and I can get 3 or 4 second exposures out of that on 300 watts of light. Pat Doyle, Mr. Doyle, are you or anyone else in the chat using strobes? If so, how many watt seconds are you using? Yes, I teach this, Pat, so I have to kind of cover what people or what they've got popular. You know who made this stuff popular, I think, are the Russians. The Russians started using, and for good reason, what are they, at 50 latitude or something up there? The Russians started using these years ago. I have a Speedotron 4,800 watt system in here. I just pop one and use one for the back. There's a guy here, Kevin Banker in Colorado, and Tim Brown. Tim, you're in here, right? You use them. Yeah, they're popular. They're faithful. You get the same look and feel every time, whatever that might be for you, and they're very familiar for people. So, okay, yeah, strobes are very popular, definitely. My favorite light to shoot in is sunlight, obviously, and not direct sunlight, north lit sunlight. There you go. Yeah. Yeah, Tim. Sometimes, Tim, you can see what he wrote. He just mixed a quick clear collodion. It was 1 to 2 stops slower than what I'm used to. So I mixed a fresh batch, and it was fast as usual. The first batch got dark pretty quick. Right. So again, that's the breakdown of the iodides. The sometimes when you heat and light will oxidize and break the iodides down faster. You can speed it up by putting it in a pan of warm water or putting it out in the sunlight. That will break down and change those colors quickly. Yeah, so your iodide or exposure, why did it turn red so quickly? I wasn't there, so I don't know exactly what your environment is, but heat and light will break down the iodides quickly. I've done an experiment where I've made a batch of my quick clear, and right off the bat with fresh iodide, right off the bat, capped it, corked it, whatever, put it in a cooler, put towels over it, and closed the cooler up. Obviously, at that point, it was a straw yellow color, and I left it in that cooler, I think, for 6 weeks, and I opened the cooler up, and it was barely darker, just a little bit darker, 40 or 50 days later. So heat and light break that down quickly. If you're using quick clear and you like the tonal range and you like what you get from it, store it in a dark, cool place. Yeah, 60 degrees north in Shetland. There you go. So yeah, strobes are a good option. Continuous light, compact fluorescent light, 5,600 degrees Kelvin, works great. Just depends on your preference of what you like to do. And Peter, not much of that here in Ireland at the moment. Yeah, Pete, I know exactly. I get it. I'm fortunate living in Colorado, so. Yes, Dale just said for Tim, would the quick aging be because of older brownish ammonium iodide? Yes, the NH4I will oxidize. That brownish is oxidation, right? I've literally done experiments where I get 25 grams of NH4I or ammonium iodide. I'll clip the plastic bag open, leave the bag open, exposed to air for a day or two. It'll start to tinge. I'll take that out, make a batch of quick clear, and it's immediately orange going to red on the first day. Now, a lot of times, if you let that sit for a couple of days, it'll slow down and then reverse back and start to change back to a lighter orange. So there's a strange, lot to do with the solvents you use. There's a strange kind of chemical interaction there. Are the different types of light affect the human skin tone? Yes. Corrado asks, different types of light affect skin tone? Absolutely. If you want the best skin tone, my personal opinion is you get down into the black light. At least put a little bit of black light on the skin. That will help with the skin tone immensely because it'll go to the melanin. The melanin's darker. If you use just CFL bulbs, sometimes strobes will do that. You'll blow them out and they'll look like just white pasty, or they just won't look good. You can get rid of wrinkles and stuff that way, but if you really want that rich tonal range, a little bit of black light down in the 300 nanometer range of light, just a little bit in there with your other lighting source, it helps a lot. My new studio points south. I try to manage with hard light. Yeah, southern exposure is tough there, Jean. It's exactly opposite of what you want. You want that northern actinic light, that blue sky. We're not after the yellow 3300 degree. We're after that 56, 57, 5800 Kelvin. UV all the way, baby. UV. Yes, that's what you want. Collodion responds. So if you look at what Collodion sees light-wise, I'll show you another little meme here. If you don't have graphic. If you don't have my book, I'll show you this here. Collodion, what does Collodion see? Let me get it in the camera here. I'm on a delay and I don't have my other one up. Black bulbs, are you still recommending the 4-foot homemade? Yes, that's a great way to go. Dale, is the 4-foot. I have some over there in the corner. I'm looking at them right now. That's what Collodion sees. You can kind of see the range there. So it's the white is mostly down in the UV, but great black light bulbs. You can get them in the U.S. You can get them at the large big box stores. They're great. Split those up. I made hundreds and hundreds of portraits with those, and they're wonderful. That's great. That's a great easy solution to do portrait lighting if you're not using strobes and you're not using natural light. I'm really excited, guys. In my new studio on the mountain, I'm going to have a north-lit studio. Of course, the non-UV glass. I might end up actually using plastic for that. More on that later. But I'm facing northeast on my studio, and my side light, the whole wall, and up top, and then I'll use bouncers over on this side. And boy, at 8,500 feet above sea level, it's going to produce some wonderful images. Thanks, guys. Auf Wiedersehen, Marcus. We'll talk to you later. I think that'll do it for me as well too. It's 11:30 a.m. here, and I got some stuff I got to do. So I'll let my delay catch up with me. And I appreciate you guys hanging with me. It's a great show. This will post up if you want to review it. And I'll try to get in here a little more often. And we're at about an hour and 20 minutes now. So that's a nice little show. Thanks, guys. Ciao.